Sebenarnya dia serupa je. Dan subject to certain conditions. Apa ni, being true lah. So, I just put here important identities. Identities in mathematics, I was told that I'm not a mathematician, that I was told by some mathematician that when you say identities, you mean that this relationship is always true. Equations may not be true. Macam dalam tulis y sama dengan 3x. This is an equation. This may not be true because kalau you plug in contohnya y 7 x sama dengan 2, this relationship tak betul lah kan. Tapi the moment you write identity, maybe this identity is 3 bar, maknanya this is always true. We have to make sure that apa yang you bukan make sure, apa yang you tulis ni, you claim that it is always true. Contohnya famous identity yang you belajar macro you belajar y sama dengan C plus R plus apa. So maknanya kalau kata tahun tu bila kita buat national income accounting, kita tengok y tak sama dengan C campur I campur, then the problem is in our bukan equation dia tak betul or identity tak betul, kita punya computation salah because they have to be the same. Okay, contohnya macam net asset, my net asset mesti sama dengan my total gross asset tolak total ataupun gross liabilities. Bila kira-kira tengok tak sama pula unit. Then there's something wrong with your accounting. Contohnya, I say my net worth is 500 ringgit. Sebab apa? Sebab I have 1 million asset, 1 million 500 ringgit debt. Net asset minus 500 kan? Dia say minus 500. Oh, net worth 500 ringgit. So my asset 1 million and 500 ringgit. Banyak duit tu, banyak. Hutang 1 million ringgit. So net worth 500 ringgit. Tapi cik drive ya memanglah, tapi hutang tengoklah berapa banyak. Cuba check if your net worth. Saya punya net worth 30,000 ringgit lah. Oh, so you are richer than me. Memanglah. Okay. So yang tu mesti betul lah. That identity is always true lah. Net worth is equal to gross asset minus gross liability. So when you say identity, I mean these are always true. Okay. BPM boleh ingat tak? BPM. Indirect utility. And the indirect utility is defined as a is defined as the maximum utility that you can get by choosing the appropriate X, the optimal X. Remember? Kita maksimal punya utility. Cara mana? Kita maksimal dengan apa? Maksimal utility subject to apa? Budget constraint, dapatkan demand function, substitute back. Whatever you get is your BPM. So your BPM is defined as the maximum utility yang you boleh dapat by choosing the optimal bundle, optimal combinations of services. Okay. Yang plotnya ini maksimal such that Px sama dengan M. This is the constraint. Maknanya you get your BPM dengan apa? Dengan memaksimalkan utility you subject to your budget constraint. So BPM is the level of utility, the maximum level of utility lepas you optimize. Okay, so this is not macam cuba-cuba. This is like the maximum utility level that you can get given apa? Your utility function, given your budget constraint. Maknanya lepas you optimize lah. Now let X star, these are all vectors sebab dia X ni banyak lah. Takkan boleh tebal lah, susah. The solution to this problem. So that okay, VPN is equal to U star sama dengan U star. Now, there's nothing special about this particular expression. Sebab yang ni is just saying apa? Lepas you maximum utility such that subject to this budget constraint, memang you akan dapat apa? Extra. So bila you substitute extra terbalik dekat sini, you extra, you dapat lah dia punya apa? BPM. So this is just a restatement lah. Sebab extra, you dapat extra dari mana? Selepas you maximum utility subject to your budget constraint. Ini satu cerita. Buka wayang baru. Lepas tu kita balik dengan wayang cerita baru. Consider now cerita baru ni kata macam ni. Sekarang ni, think of an expenditure function. Okay, so okay tak apa, think of an expenditure function. Expenditure function dia punya definition apa? Is the minimum expenditure required to achieve a certain level of U. Katakan you yang you nak capai ni is U star, yang macam dekat atas tadi. Okay, this is the crucial step lah. You really have to appreciate this. You dapat you punya indirect function by apa? Maximizing utility subject to your budget constraint. Bila you substitute balik, you dapat apa? You dapat this VM lah, which really is, kita boleh label dia sebagai apa? U star, you label dia sebagai U star. That is the maximum utility yang you dapat, given that you have to maximize the utility subject to this constraint. Kemudian kita kata, okay, now we want to find an expenditure function, and the level of utility yang kita nak capai itu adalah apa? Adalah U star. Maknanya the level of utility yang you dapat bila you maximize you punya utility subject to your budget constraint. Okay. Now, if you want to do that, then what you want to do is you minimize your expenditure, which is P times X. Tapi now, the utility level that you want to achieve is, instead of just U, you want a particular level, which is U star. Dulu pun particular level lah, tapi kita tak define what is that level. So now there is U star. What is U star? U star is apa? The level of utility yang you achieve macam under this utility maximization program. Then X star, which is really apa kat sini? Kalau kita dapatkan, kita selesai ni, kita dapat X1, X2, X3, tapi dia tak Xn apa? Xn 5. So this is your H, if you like H star. Buang answer ni tak confused. I know now you look at it, I don't see this one. Okay. Bila you minimize expenditure, okay, subject to you achieving a given level of utility U star. Macam kat sini. Macam kat sini. What you get is H star. And now I'm making a claim. Saya dah beritahu di bawah. This H star, it should be the same as X star yang you jumpa ni. Yang through, you find through utility maximization. Should be the same. Well, nampaklah ada some relationship kan. Sebab, okay, think about this. Utility pengguna ni sama tak? Dia punya utility function sama tak? Sama kan? Okay. And then you kata, okay, you maximize your utility subject to budget constraint. Mula-mula. Okay, what demand function do you get? You kata you dapat X star. X1, X2, X3 kan? Okay, now you kata, I want now you to minimize your expenditure. Tapi subject to you achieving the same level of utility kat sini. What will be your combinations of goods and services? Now, logically speaking, kalau utility function is the same, the only way for you to get the same level of utility should be when you purchase the same combinations of goods and services. Sebab tu kita make this claim that H star should be the same as X star jika you try to achieve the same level of utility macam ni. Okay, some of you may not be that convinced. So what we do is kita lukiskan this diagram. Okay, this is X2, this is X2. Okay. Kalau dalam kes memaksimalkan utility, you kata macam ni. Oh, I have a budget constraint. This is my budget constraint. What I am trying to do is to get onto the highest indifference curve possible. So you end up, contohnya katalah, you end up whereby you beli X1 star, X2 star. Kenapa Encik beli? Because this is the point where I get to my highest indifference curve. Now, this highest indifference curve gives you utility level, kita label U star. Now I ask you second question. Suppose you now want to achieve a level of utility. What level? U star. Tapi now instead of maximizing utility, you minimize your expenditure. So you get rows upon rows of budget constraint. Cuma you try to go to the lowest one, and the lowest one has to be sini lah, yang ni. Sebab you nak achieve U star. Kalau you pilih expenditure ini, of course you can achieve U star by sitting here, but you are not minimizing expenditure because you can go down further. And the furthest that you can go is when you sampai dekat line ni, asal tadi. If that's the case, then you must be choosing the same combinations of goods and services. So in other words,
Is it the same with identity that you are trying to prove here? Is it the same as the statement minimizing expenditure to maximize utility?
Okay, minimizing expenditure. The combinations that these are not yet the identities, or these are prelude to the identities that I'm going to show. But no, the identity is not yet. The identity yang EP, U, sama EP, VM. But you need to understand this in order to understand the next 4 or 5 identities that I'm going to show you lah. So this is a very important precondition in order for you to appreciate the subsequent identities that I'm going to write on the board. That's my point. Okay. Maybe I should try to do this again. Okay. I think most of you do not have any problem appreciating the fact that in order to find X star, which is your Marshallian demand, what you do is you lukis your budget line, kemudian you try to get to the highest possible indifference curve. Why? Because the highest possible indifference curve gives you the highest utility level that could be achieved by the consumer. Okay, so let us draw one such budget constraint. So this is your budget constraint. So under utility maximization, what you do is you keep shifting your indifference curve to the highest one. And it so happens that this is the highest indifference curve that you can get onto, given your budget constraint. Which implies, therefore, that the optimal choice for you is to choose X1 star, X2 star lah. 3,700 contohlah, 3,000, 7,000. Okay. Now, I'm saying, do the reverse side of the coin now. Apa dia? Expenditure minimization. Now, you have a problem to try to find the combination of X1 dengan X2 such that you minimize you punya expenditure while at the same time attaining U star. Okay, so you say, okay, saya nak capai U star ni, tapi difference curve kenapa tak berubah? Because you are the same person, kan? You are the same person, kan? So technically speaking, you punya difference curve should still be the same, kan? Okay, so since you want to achieve U star, then you say, okay, how do I minimize expenditure? Well, you know that your budget constraint, the position of your budget constraint tells you the level of expenditure that you have to make in order to get onto the budget constraint. The higher it is, the higher will be your expenditure. So what you say is, okay, now I try to minimize my expenditure. So you keep minimizing your expenditure. And you cannot minimize it further more than this particular level of expenditure. And of course, when you choose this particular level of expenditure represented by this budget line, kemudian you punya indifference curve pula serupa macam yang tadi, of course you will still choose X1, the same level of X1 and the same level of X2 under both conditions. Okay, so what I'm trying to say here is that your choice, okay, tak kira you buat utility maximization ke ataupun expenditure minimization, your choice will be the same as long as you are trying to achieve the same level of utility. Identity nombor 1, E, P, I know you say, I don't see how this thing comes about. Tapi I want to tell you, dia punya understanding ni comes from the understanding of the previous analysis. Okay, I'll try my best to explain this to you. I think most people would need some time thinking about this. At least this is my personal experience. When I was first shown this identity, I don't quite appreciate it. Okay, baca video buku, dia main dengan buku apa semua, lama baru lah, lepas 2-3 hari baru, oh maybe you can do it. But some of you are smarter than me, I know. So you may probably, you can probably comprehend this faster than me. Okay. So think about E. E apa? Is your expenditure function. Okay. So this is not like macam P1 kali X1 campur P2 kali X2, NEP, no, this is a particular one. This is like the minimum expenditure. Okay. This is like after going through the expenditure minimization program. Okay. Having a certain level of utility turunkan to a certain to the optimal point. Okay. So now we are saying the minimum expenditure required to achieve apa dia? Ni. The utility level that you could get if you have how much money? Pendapatan apa? How much income? M is equal to M. How do I explain that? Okay. E is your the minimum expenditure. Okay. And then I tell you the minimum expenditure, okay, required to achieve this level of utility, because this is indirect utility kan. When you have income equals to M, mestilah sama dengan M. You would have sama je. I don't see why that is the case. Okay. So when you have problem like that, you always go back to this kita punya magic little diagram ni tadi. You always say, okay, let me try to understand this. This is x2, and this is x2. Of course, that x can be many, tapi kita senang kita buat diagram. So you say, okay, this is my expenditure function, ataupun my budget constraint. Depending, kan? Could be your expenditure function ataupun your budget constraint, depending on which program you adopt lah. Kalau you try to maximize utility, this is your budget constraint. Kalau you cuba minimize your expenditure, this is your expenditure. So then I'm trying to achieve this level of utility. Okay. So now let's look at first utility maximization. Kalau you nak maximize utility, apa you buat? You gerakkan your utility function in difference curve, hold your budget constraint constant. Akhirnya you dapat apa? Achieve a given level of utility lah. Tadi kita label dia U star, tapi sebenarnya apa? Sebenarnya dia VPM lah. Because U star is sama dengan VPM. This is the level of utility. Now, I'm saying this is not your VPM though. I'm saying this indifference curve corresponds to dia adalah indifference curve yang berpadanan dengan, okay, kita dapat utility level V. Dia kata sebab apa pula? Dia kata sebab V ni is defined as apa? The maximum utility that you get given your budget constraint. Okay? Oleh itu, whatever is V yang you dapat di atas apa? Indifference curve ni, itulah dia VPM. Kenapa pula? Sebab VPM is the maximum utility yang you dapat melalui apa? Proses apa? Utility maximization problem ya. Given apa? Prices and dia punya utility function and income, of course. Given prices and income, function is given. Given prices and income. Okay, let me ask you this. When you achieve this VPM, what was the level of income yang you had? M. So this is M. This is not M lah. This is the budget constraint that you get bila pendapatan UM. Kenapa bukan M tolak 10? Yalah sebab yang ni, this is my budget constraint. M tolak 10 is not my budget constraint. My budget constraint is equal to M. I spend all my money kan, all my income. So be careful lah bila cakap M ni bukan this is M tau.